Challenge activity 3.3.1. Now we're talking about the correlation coefficient R. This is up until now we've been looking at scatter plots and residual plots to kind of get an idea of the correlation, but now we're going to dig a little deeper into a more standardized metric, R, the correlation coefficient. Remember, this goes between -1 and 1. The closer to 1 or -1, the more strong the correlation. When it's close to 0, that means there's no correlation. And anywhere in between, maybe like 0.5-ish, somewhere around there is going to be like what we would consider moderate correlation. Remember, if it's positive, that means positive correlation. Negative means negative correlation. And as we talked about before, positive correlation means that as X increases, so does Y, and negative correlation means as X increases, Y decreases. As we can see here, we've got 3 scatter plots. It says match each scatter plot to the corresponding correlation coefficient R. The idea is just to get a better idea of what correlation, strong, moderate, and no correlation look like in a scatter plot, look like with the correlation coefficient, and how they relate to the regression line. So here and all these are positive, as we can tell, because they all have a slight increase, or excuse me, increasing pattern. As X increases, so does Y. So this first one, as you can see, all these data points are extremely close to the regression line. So you can tell there that it's a very strong correlation. So we would expect this correlation coefficient to be very close to 1. So as we look at the options, we have 0.282, 0.637, and 0.9. I would say just from looking at that, it's 0.9. It's a very strong, sorry, that's my cat. It's very close to 1, so it's very strong. So we're going to pick 0.993. Now for the next two, it might not be as obvious, but again, we're looking at the difference. What we have left is that 0.2 and that 0.6. 0.2 means that there's almost no or very little correlation, whereas 0.6 means that there's a pretty moderate correlation. And I'm going to kind of compare these two to help us understand it a little bit better. So one thing I would say is that just looking at this, it looks like the slope of this line is a little bit higher. The data points appear to be a little bit closer to the line than in this scatter plot, whereas the line is a little flatter. The points seem to be a little bit farther away. So what I would say is that this one shows moderate correlation with the correlation coefficient of 0.6, and this one shows very little correlation with that correlation coefficient R equal to 0.282. Let's check. Yep, everything's good. Nice green check. Let's go to the next section, or next part, excuse me. Here we have an online retailer trying to determine how positive reviews of items affect sales. The plot below shows the relationship between the number of positive reviews and the number of items sold. The linear regression output is shown below. So this is what you see when you do your the data analysis pack linear regression out of Excel. So this also just gives you an idea of what we're looking at. So here we have number of positive reviews on X, and we have the number of items sold here on Y. So you have R squared. Remember, that's the measure of the variance in one explained by the other, but then here's our multiple R. That is our correlation coefficient. So we're just going to type in 0.968133. That's our correlation coefficient when it says multiple R, like right there. And it says, what is the correlation between number of positive reviews and the number of items sold? Is it moderate, strong, or weak? Well, it's pretty close to 1, so I would say that it's a strong correlation. If you saw something down there like 0.6, 0.5, 0.4, we would definitely say moderate to weak, depending on the situation. So let's check. Nice little green check. That's it for this challenge activity. If you have any questions about this or anything else, let me know.